Welcome to Study Loop.
Let's evaluate this integral by trying a trig substitution. X equals secant theta. And the motivation for this choice of a trig sub, is based on not necessarily the radical, but more so the term x squared minus 1. So this is a number of the form x squared minus a squared. And when you're in this case and you want to use trig sub, then this is the trig sub that you should use. So here, differentiate. So that's our right-hand side. And then now we can rewrite this integral. So dx up top, I can replace that with this. So I have secant theta, tan theta, d theta up top. And then on the bottom, secant cubed. And then we'll have square root secant squared theta minus 1. Now here we know that secant squared theta minus 1 equals tan squared theta. This is one of your Pythagorean identities. So when we take the square root, we just get tan theta. And so we can go ahead and cancel this tan theta here with this tan theta up there. And then we could cross off this secant with one of these, and we have 2 left on the bottom. So we have 1 over secant squared. And we could rewrite that as the integral of cosine squared. And then use the half angle identity for cosine. And we could integrate both of these terms. If this 2 theta is bothering you, feel free to do u sub here. You can do u equals 2 theta. And we have 1/2 theta. And then we have sine 2 theta. And we'll have a 2 from this over here. And then we'll get another 2 from the u sub. And then here, we can rewrite this using the double angle formula for sine. And then we could cross off that 2 with one of the other 2's. So we have 1/2 theta. So let me just write that as theta over 2. And then sine theta cosine theta over 2 plus c. Now let's evaluate each of these 3 terms. And these will all come from our u sub. So for example, if I take inverse secant on both sides, I find theta. So I can rewrite this answer as secant inverse of x over 2. And then now I need to evaluate sine and cosine. So this is where I go to the triangle. So we did secant theta equals x over 1. So that gives us x divided by 1 if we're calling this angle over here theta. And then by Pythagorean theorem, we get the remaining side. So now we could go ahead and find sine and cosine. So sine opposite over hypotenuse. So we have over x for sine. And then for cosine, adjacent over hypotenuse, so that's 1 over x. And then we still have our 2 down there. And the last step here is just to simplify this answer a little bit. Secant inverse of x over 2. Square root x squared minus 1 over 2x squared plus c, and that's our answer.